Okay, good afternoon once again. So, we had done some brief introduction to SAP ISU billing in the last session. So, with that introduction, we'll start our next session. So, I happened to mention in the previous session, ISU billing is the most critical component of SAP ISU solution. ISU billing as an application module can be subdivided into two parts. One is billing master data, also called as rate structure, also called as rate structure. And then we have billing execution, billing execution. Now, just, just let me quickly take once again through what is the scope of ISU billing or billing in the ISU solution, the context of billing. Every solution has billing as a module, like we have billing module in sales and distribution, we have billing module in oil and gas, we have billing module in, let's say, the telecom, or any such solution where we are either providing some products or services, and for that we're going to do billing calculations through a billing document. And then depending on the situation, either the billing document will itself act as an invoice, or once the billing is done, we are going to prepare the invoice. So billing is basically a process where we calculate various charge amounts, various charge amounts as per the procedure fixed by the company. That means for every billing, in a certain way, you're going to calculate various charge amount. These charge amounts are calculated for individual line item. Like for example, if you take sales and distribution, you start with the sales order, then you do delivery, post-code issue, then you do billing. In billing, system will calculate various line items in the form of the conditions. Like we have how much is the price amount consumer has to pay, any discount applicable, discount amount calculation, then freight amount calculation, taxes, duties. Individually, all these are called conditions in SAP SD, and for each one of them, system will do the calculation. And then these are the amounts what you're going to collect from the consumer or the customer by adding the tax. So this is how it actually happens in the case of sales and distribution billing. Also, in case of sales and distribution, we said billing is the last application component. After that, there's no other module in the SAP SD. And billing in sales and distribution is tightly integrated with the FI module. That means SD and FI integration will happen. For each and every condition, the system will do automatically account determination, revenue account determination, tax account determination. The reconciliation account is fixed in sales and distribution. When you create a customer master in the company code level, there we maintain the reconciliation account. So system does not have to search for the recon account, but it has to find out all the revenue accounts and the tax accounts. And then when the billing is executed in the background, automatically it will do the posting to GL accounts in FI, thereby an accounting document is created. But coming to ISU, billing is not the last application. Rather, after the billing, we do next activity of creating the invoice. And invoice is again not directly posting data into FI. Instead, it will post a document in FICA, the sub-the accounting document. So we start with the creation of metering order and then read the meter, MR, read the meter, and then enter the MR results in the system. And then it will do meter reading validations. Only results that are approved will go for billing. Then we execute ISU billing. The billing document is prepared. And once the document is prepared, in the document, various line items are calculated. For the energy billing, we can say electricity, various energy line items are calculated. But unlike sales and distribution billing, here it will not do any tax calculation. Except the tax, all the line items are calculated. And then after the billing is done successfully, again it will be validated. The approved billing documents will be taken for the invoice preparation. So invoicing and billing are two separate applications in SAP ISU. Whereas in sales and distribution, they are one and the same. Umbrella, the billing is the umbrella term under which you create different types of invoices. But in ISU, there are two scenarios. One is we do regular conventional billing, and then referring to billing document to create an invoice, which is also called the print document. And when the invoice is saved, it will not post directly any information into FI. For each and every invoice, there will be a corresponding FICA document posted, a document posted in the FICA sub-ledger accounting environment, and it will update the receivable at the contract account level. But the FICA document will also have the GL items, but these GL items are not posted immediately to FI. End of the day, we close all these FICA documents, thereby system will summarize the or aggregate the data for each of the GL account. This aggregated data will be sent to FI. That we're going to see in the future when you start working with the invoice module. So here we have a situation where you first do billing execution and then we do the invoice preparation. But in another scenario, meter reading will not happen periodically for certain months. Like in the case of budget billing, you do not do meter reading every month, rather once in a year. In between 11 months, we prepare what is called budget billing invoice. So there's no meter reading, there's no billing. Directly we prepare an invoice, which is called budget billing invoice. And again, it will post the data to FICA. So we will see that part in future. So in budget billing, there are three scenarios. We will see them separately. So coming back to billing execution, it's a part of the meter reading to cash process. Now, in the case of billing process, first we have to configure and maintain all the required data in the form of billing master data. Normally, when you say master data, it is the application data, the data that you maintain in easy access. You can say end user data, like customer master, or let's say the material master, or product master, or you can say business partner, contract account, connection object. These are all basically application data, master data. But coming to ISU, billing master data is a misnomer. It is not a end user data object. It is not something that end user will maintain in the system. It is part of the configuration. That means the ISU consultant has to customize the billing master data, and all these customization activities normally you do from the IMG. But in the case of billing, SAP has also added those activities in easy access. That means either you can set up the billing master data from easy access or from IMG. Whichever way you do it, the data will be saved with the customization request. That means after testing, you have to transport it to your quality system, then to production system. So it is the job of the not the end user, but rather the functional consultant, ISU billing consultant, you can say. Now, billing master data is also called rate structure. The billing master data is set up specifically for a particular division. Entire billing module is structured based on the division, what is called utility division. In the enterprise structure, we have defined three divisions, one for electricity, one for gas, one for the water. The billing master data will be structured for each and every division separately. But again, for each division, there may not be only one set of master data. Depending on the scenario, we may have to structure more than one set of billing master data. Likewise, billing execution also, we are executing billing document for a contract, and the contract is division specific. If, say, for example, consumer is having all the three contracts, assuming that the company is providing all the three utility services, there will be three separate contracts, one for the electricity, one for the gas, one for the water. When the billing happens, billing will be executed separately for each contract. We cannot process the billing for all the three contracts in one single billing document. But after the billing is done, we have a choice. Either you can separately create an invoice for each billing document, or you can merge them together in a basically joint invoicing, depending on the requirement. So as far as the billing is concerned, the master data, billing execution, both are division specific. Now, billing master data basically enables to map all the existing procedures, laws, or methodology, what is used by the company to do the billing calculation. The billing calculation of the line items happens based on the billing master data. So unless the billing master data is maintained completely validated, we cannot execute the billing execution. So our first scope of understanding will be to set up billing master data for a particular scenario. Now, basically, billing is not one-time configuration. At the time of implementation, based on the existing requirements, we will customize the billing master data rate structure. We implement by testing and then moving into production system. As a company starts using the existing billing module configurations, in future, as and when there are any changes that bound to happen, because billing is basically a very dynamic activity. It keeps on changing depending on the change of the rules that happen in the billing, either because the company wants to change it or there are some legal requirements. So at that point of time, again, we have to do the new billing module definitions for the master data or make certain changes in the existing master data. This is an ongoing work that happens in the support project. So a billing consultant will be always required because these are expected to happen on a regular basis in the existing system or the production system. So as I said, billing master data is maintained in the system, which we can map all the parameters required for billing execution. So basically, we are going to establish the billing procedure or the rule or the logic with which the billing calculation should happen. The billing master data contains various parameters. All these parameters we have to define and then connect them together. Once they are all connected, it becomes the complete master data or the rate structure. So let me first list out what are all the parameters we require. Some of the parameters are already provided by SAP. Otherwise, most of the definition we do is from scratch. That means we are going to define the enterprise structure in the enterprise structure division. And for that division, you're going to build the billing master data. Having said, SAP would not give any data because it is our division what we have defined. But there are some system related data that you can use. And even them also we can define, but not through the configuration part, but necessarily through development. The ABAP team will come to picture. So what are the various parameters involved in the billing master data? Let me list out. First, we have something called billing class. Then we have the variant programs. Variant programs. Then we have operands. Then we have rate or rates, we can say, because sometimes one rate could be good enough, but sometimes you may have to define more than one rate. So you can say rate or rates. Then we have schema. Then we have rate category. Now, actually, there is something called a rate type that you can even define even before we define the variant program. But it is something that you can define at any given point of time. But while learning, always I keep it in the last because we need to understand what is the significance of the rate type. That's why I don't do it in the beginning, but somewhere before you do the, like say, for example, let's say first you don't define the rate type. What happens when you do device installation in billing? That time you will understand why the rate type comes into picture. But there must be a rate type defined. Again, rate type can be one or more. If we have defined three rates, then there will be three rate types. If I define 4 rates, then there will be 4 rate types. Then using the rate type and the rate category, we do the rate determination. This is the most important activity. Apart from the rate determination, we also maintain the price master, and then also we maintain the surcharge master, surcharge and discount masters, charges and discounts. So these are also maintained as a part of master data. As I said before, most of them, almost all of them, except maybe variant program, you can have them looked in the easy access, define them, but you can also do it from the IMG. And whenever you define change, it will be saved with the customization request. Now, among the 10 objects what we defined, there some of the objects are going to integrate with the other objects. For example, when you create a rate, for instance, while defining the rate, we have a integration with the FICA module. That means you need to define certain parameters in the FICA module. Then only you'll be able to portion to create the rate. That means rate has got a direct integration with the FICA module. Then this rate category, what you define in the IMG or as a part of customization, this rate category will go and sit in the technical master data, that is utility installation. Technical master data, utility installation. We have not done utility installation so far because we were not ready with the billing master data. That's why we're not done. But actually, when you define a rate category, it will go and sit in thousands or millions of utility installations. That means rate category is spread over millions of installations in the system. That means all of them contain a particular rate category. The rate type, depending on the situation, usually rate type will go and sit in the device level, device installation, either at device level or register level That means again, this is a kind of integration. That means the rate type what we define will go and sit in the device installation when you do billing installation at the device level or register level. Sometimes we may not do the device installation. There are some installations where there is no device. For example, street light. In that case, it will be maintained in the fax. Fax is another object in system. So either you maintain the rate type at the device installation level or at the fax level. And based on this only, rate determination will happen. The price master, what we define, is again going to be stored in the fax. Facts are also available at 3 places. We'll see them. So most of the master data, what you define here, all these going to be integrated with the other objects in ISU. Now, surcharges and discounts also will be stored in the facts. So this is in nutshell the head count of all the various billing master data objects what we define. Now, obviously, this complete parameters what we define are defined keeping in view of particular scenario. Let's say I want to do ISU billing for a 2 rate meter, 7 economy meter. Then I'll be defining the complete set of master data for 7 economy meter or 2 rate meter. Or I'm going to define again same set of master data for a single rate meter or a 3 rate meter or a smart meter or water meter or a gas meter or for the smart meter billing RTP. So the entire set of master data what we define is not for the only one billing scenario. Depending on several billing scenario, for each scenario you are going to maintain a dedicated set of master data. But however, some of the objects what we define here are reusable. They can be used in more than one place. For example, variant programs, operands, all these you can use in more than one scenario if required. That means there's no as such constraint. but certain things are linked to certain, objects only. For example, the rate, sorry, rate or schema rate category are dedicated for a one particular scenario. We cannot use them in other scenario because billing class will change. So basically, what you're trying to say is these are all the billing master data objects. What we define. Just give me 1 second. Sorry for interruption. I'm back. Yeah. So I have listed all the parameters which together form the complete rate structure. Now, before you start defining all this data for our divisions, we will take a look at the existing data just to see where all it is defined, how it is connected in the system. Okay. So that give us the some idea about how these are embedded in the system in various objects. So what I will do, I'll try to go to first one existing installation because in the technical master data, installation happens to be the most important, highest level data. Although we start with connection object, then we start defining premises, device location. Finally, for each premise, we're going to create a installation. Installation is the basic framework, which is a very essential data object. Only when the installation is created, we're going to create the contract. And we maintain all the required parameters in the installation level about the billing master data. So let me open one of the existing installation for electricity division and try to look around all these objects what you have defined or what are going to come into the picture. So let me open one of the existing installation data. We will go to technical master data installation and then change our display. We have certain divisions in the system for which you already done the complete configuration. Let me find out the division. Maybe I will take 93. This is the electricity division. For 93, we have so many installations available here. Let me take installation 83. Let's see what is there in this. Basically, as you know, installation is basically a master data object linked with the premise and division. Each premise can have a specific installation for each division. Here, this is a installation which is vacant now. It was occupied earlier, but we may have done the move out process. So right now it is vacant. But here you can see when you prepare the installation 83 for the premise 82 for the division 93, we had maintained certain master data objects here pertaining to billing module, billing class G930, and the rate category. So as you listed in the our lecture, billing class also will go and sit in the installation. and rate category also will go and sit in the installation. So basically, the billing class and rate category are part of the installation data. And then here we have the facts. Now, either I might have maintained facts at the installation level or at rate category level. If I go to rate category and see the facts, we have got some facts information. Here we can see in the facts within the rate category, we have maintained information about the two different prices. One is the on-peak energy, one is the off-peak energy. G9302, G9305, these are the price keys. We define them as the prices. So if you double click, we go to price key. Actually, G9302 is the operand actually. It is connected with the price master identified by 71. So 71 is basically price key where you have maintained information about the on-peak price. So you have maintained in the historical timeline from which date to which date per kilowatt hour, what is the price. So we have defined this information. This information is defined separately as a price key, but we have connected with the operand in the billing master data. Likewise, we have G9305 off-peak energy price, and it has got a price key 72. So basically, we have defined the price keys and linked them with the operand related to the prices in the facts. The facts can be maintained at the installation level, rate category level, or rate level. Why we have three provisions, we will understand as we go along. So you have seen the billing class, you have seen the rate category, we have seen the price master, how it is linked to operand. But where is this operand? Where we have defined. So let's go to, in the particular installation, let me go to billing periods. Here, all the billing master data objects are stored here, rate type. Now, in our particular installation, we're going to do the billing execution with the two rates. That means that two logics will be used for billing line items calculation. One particular rate is G930 and another is billing rate is G9301 and G9302. That means there are two rates. Why two rates are coming? We'll come to know as you start working. Now, the rate is part of the billing master data. Combining these two rates, we have got a schema. That means one billing schema will contain all the rates required. In a situation, you may have only one rate. Sometimes you may have more than one rate. Whatever rates you require, you define them independently first. Once all the rates are defined individually, we put them under a schema. So you can say schema groups together and one or many number of rates into one single block. So you can say schema contains all the rates, all the corresponding variant programs in which sequence the variant programs have to be executed. And this billing schema is sitting under rate category. So if you go to rate category, this is a rate category defined in the IMG, G930 as a rate category for division 93. This rate category contains the schema. The rate category contains the schema. In the schema, we have got schema steps. In the schema steps, you can see what are the rates we have used. So there are two rates which are defined, G930-2, G930-1. So let me go to the first rate. Each rate has one or many steps of calculation. That means if suppose here we are able to see only one line, that means it is calculating one line item. So if the particular rate is having three lines, it means it is going to calculate three line items basically for the billing. Now in the rate steps, we have got a variant program and then we have got the operands. So the rate contains the variant program and the associated operands. If we have three steps of calculation, each step of calculation is performed by a particular variant program. And for the execution of the variant program, you define certain operands. So these are the operands which are used in this particular scenario. Again, operands are defined into two categories, input operands and output operand. So input operand number 1, input operand number 2, and output operand. Now, it's not that always you require two inputs. Sometimes it can be only one input also, depending on the documentation structure, what is maintained for variant program, we come to know what are the requirement of the operands. And each of these operands are created for a operand category. So if you double click the operand, we come to operand definition. This particular operand is defined for operand category quant. That means this is for the quantity. Like that, if you go to G98302, this operand is defined as a category for Q price, and the third one is defined for the amount. Amount is a category. So we have defined first the operands, and how the operands are defined, taking into consideration in which variant program we're going to use. So first you have to know which variant program is required. Then based on that, we know how many operands are required. We define them. All these definitions of the operands will happen at the division level. That means they're specifically created for the particular division. Now, this particular rate also has 4 important columns here: debit sub transaction, credit sub transaction, budget billing, debit sub transaction, budget billing, credit sub transaction. This 9300, 9399, what you see here, these are the parameters defined in the FICA module. So if you double click, it goes to FICA definition as a debit sub transaction. We have assigned the combination of main transaction, sub transaction to our company code. So here you can see 9300 company code, 93 division, 0100 is the main transaction, and 9301 is the sub transaction. For this combination, we have maintained whether the sub transaction amount to be debited to contract account with the tax. Of course, all this will come in detail when you start working on the billing master data. So over here, you can see an integration is happening between the billing master data and the definitions what you have done in the FICA. Now, after that, we have got the rate determination. For that, we have defined the rate type. So where is the rate type here? Here you can see rate type. Now, there are 2 rates and we have got 2 rate type. For each rate, we should have a dedicated rate type, because each rate type will help us to determine the particular rate. And for that purpose, the unique, determination will happen. G9301 has been defined as a rate type. We cannot directly go from here. We'll go and see it in the easy access. But now, rate determination is also maintained separately. So if you go to our billing master data, you can see from here, billing master data. That means you can define the rate type, operands, prices, rate, schema, rate category, rate determination. All this you can do it in easy access, but you can also do the same thing in the IMG. But whether you do from here or IMG, saved with the customization request. For example, if I go to define the rate determination or rate type, if you go to rate type, here you can see G9301, G9301 rate type. So here you can see G9301, G9302. One is the rate type for the on-peak register, one for the off-peak register. So because we are having 2 rates, we have defined 2 rate type. Now, where is the variant program available? If you go to IMG, you can find out. So let us see step by step what are the steps available in the rate structure definition from the IMG perspective. So go to utilities and we go to the contract billing, billing master data, define billing class. That means we'll be defining our billing class over here. And then we have rate structure. In the rate structure, they are given the step-by-step definition. But now, some of them can be defined at any given point of time. You don't have to define all of them in step-by-step. In sequentially, you don't have to define. But yes, there is some dependency. For example, unless I define the rate, I cannot create a schema. Unless I define schema, I cannot create a rate category. Unless rate category and the rate type is available, I cannot do the rate determination. So there is a dependency, but variant programs, operands, prices, all these can be defined at any given point of time. Now, variant programs are something given by SAP. These are small programs defined or maintained in the form of function module program. So when SAP delivers the package based on their global requirements, they have already structured various variant programs. There's a huge list of variant programs ready to be used. That means they are already provided by SAP. Among the billing master data, only two important objects are available from the SAP. One is a variant program. That means variant program is delivered by SAP. It is delivered by SAP. But apart from what SAP has delivered, if there is any logic required for the line amount calculation, if it is not available in the SAP, then we can have it defined in the billing master data corresponding to our definition of the variant program. The ABAP consultant will have to define the functional model program. So it comes under the system modification. Under system modification, we can add our own function model programs in the form of variant programs and link them with the variant program, what we define. So variant programs are given by SAP. Then rate type is our definition. So here we define various rate types. Now comes the operand. Now, operands you're going to create for the project, for the particular division. But when you create the operand, you have to specify the operand category. The category is system defined. There are system defined categories, about 20 of them. These are delivered in the system. These operand categories are not configurable in this standard scenario. I mean, you're not supposed to touch any changes, but it is configurable. You have to go through another transaction, I tell you. So if you go to any of the operand, if you try to see display, if I go to any of the operand, let's say this is operand. Here, this is the rate type, you can say. This is operand category. There are 20 predefined operand categories available. That means these are already available in the system. So this is another important set of data provided by SAP. So SAP will give only two parameters. One is the variant program, a list of various variant programs available, and you must know when particular variant program has to be used. Second is, whenever you want to create any operand, at that point of time, our definition of the operand will happen for a predefined rate category. You can say the operand category is a classification of operands. Like in sales and distribution, I don't know whether you have worked in that module. In sales and distribution, we define condition type. A condition type for price, condition type for discount, condition type, let's say, for freight. Each of the condition what we define is defined to a conditional class. Conditional class is fixed in the system. That means each and every condition type belongs to a particular conditional class. Condition type, SAP will give, but if you want, you can also define. But whenever you define, it has to be connected to a conditional class, which is given by SAP. So condition type, conditional class basically classifies the conditions from the pricing calculation. Likewise, operand category provides classification of operands. That means each operand belongs to one particular operand category. So how to make use of them, we will see. So the variant programs and the operand category given by SAP, but we define the operands. Then we have the price master. The price can be created from the easy access or from the IMG, like we have defined prices. Rates we define here, one or many rates. And then once the rates are available, we create the schema. In one schema, we'll have one rate or many rates. The rate, schema, rate category, all these belong to one billing class. That means if I define a rate type for, if I define the rate for one billing class, it can be put in a schema belonging to same billing class. So what is the purpose of billing class? We will see. So schemas are defined. One schema that is defined will go and sit in the rate category. Rate category, you can say, is the final definition, highest level data in the billing master data. And this will go and sit in the installation level, what you saw just now. Then we maintain the rate determination. Apart from this, we have a separate section where we count in surcharges. That means when you define the prices, there's a separate transaction for that. But we cannot use the same transaction to define the discount and surcharges. So discount and surcharges are separately defined, but they are also integrated with the facts. Okay. So this is the complete, step-by-step activity what you can do in IMG as far as the billing master data is concerned. So obviously, to start with billing master data, we are going to start with the structuring the billing master data for a particular scenario. Okay. First scenario, what you want to consider is setting up the billing master data for a residential consumer two rate meter. Two rate meter. Although I could have done with the single rate meter, which will also come subsequently. Then you'll have smart meter, then you have fax billing, street light. All this will do step by step. For commercial consumers, industrial consumers, we will try to create them separately. But idea why I'm taking two rate meter is we'll be able to understand more clearly the concept of rate type. That's the reason I'm going to start with the two rate meter. Basically, what is two rate meter? We have explained that in the device management. Our meter will have two registers. One register will be called as on-peak register, one will be called as off-peak register. On-peak register will provide the consumption data, consumption recorded in the period morning 8 o'clock to night 9 o'clock. Then from 9 o'clock to midnight and next day morning 7:59, whatever consumption happens, it is stored in the off-peak. That means you can apply two separate prices. On-peak price will be higher, off-peak price will be less. And we want to give the benefit of consumption happening in the off-peak period to consumer, so the price is lesser. So we are going to define two prices, two amounts will be calculated, and our register also are defined in that way, where each register will show us the complete consumption data for each month or each period when you do the meter reading for a particular type of register. That is on-peak register, off-peak register. So we are interested to develop a billing master data for residential consumer with a two rate meter. This is our definition of the billing master data. And obviously, this is done for the electricity. You can say this is for the electricity division. First, we'll try to understand what is the purpose of billing class. What is the role it has to play in the overall billing master data. So we'll go to the billing master data definition. Go to contract billing and billing master data. Define billing class. Now, billing class is a 4-character key. What to define? Billing class itself does not have any control. It is just an identifier. There's a 4-character key and a proper definition, but on its own, it does not control anything. But it is most vital, important definition. It is also used as a permissibility factor. It has got dual responsibility. That means it serves two functions. One purpose of billing class is it groups together n number of installations which require the same logic for billing. You can say billing class. One billing class, what I define, will go and sit in thousands or millions of installations. So you can say groups together n number of installations which require the same logic of billing, same logic for billing. Let's say in our total installed consumer base in the particular service territory, we have residential consumers where 80% of the consumers are having two rate meter, let us assume. That means out of 100, 80% of the consumers are having basically two rate meters. That means if our installations are going to be like 50 lakh installations, out of that 40 lakh installations are two rate meter. Each installation is maintained for a particular premise. In all these 40 lakh installations, we are going to maintain the same billing class. So basically you can say billing class groups together n number of installations which will require the same logic. What is the logic we require? We require a logic for the billing calculation for a two rate meter for electricity for a residential consumer. So it groups together n number of installations which require the same logic. Another important purpose of billing class is it is acting as a plausibility factor. That means whenever you define the rate, we define the rate for a building class. Then whenever you define a schema, you define for the building class. We define the rate category for building class. All these three objects can be connected if they are all provided for the same building class. Suppose I define building class as XYZ. That means I created a rate or rates. All these rates belong to building class XYZ. Then I have defined the schema, which is also defined for basically building class XYZ. So if I define the schema for the building class XYZ, generally I can put the rates defined for building class XYZ. It's like a permissibility factor. We can never go wrong. Suppose I created a schema for a building class ABC, okay? But my rate belongs to building class XYZ. That means when I create the schema, I cannot put the rates which are defined for building class XYZ. So it will be acting as a permissive factor. Similarly, I create a rate category. If I create a rate category, for building class 1 to 3, in that case, you can say in this rate category, I cannot put the schema because schema belongs to another building class. So building class is a permissibility factor. It will help us to connect all the parameters which need to work for a particular scenario. My rate, schema, rate category have to be available for billing or doing the billing line item calculation for a residential consumer with the 2 rate meter for the electricity division. So all of them should be having the same billing class. Now, first we'll define our building class here for our requirement. Like that, in future, we're going to have so many building classes defined for each scenario. So let's see how to define the building class. Right now, I'll make some provisions so you can understand. So in future, how to use. Now let me go with the new entry. Let me say G01. Then ZG02, ZG03, ZG04, ZG05. This I'll say residential consumer 2 rate meter electricity division. Then I will say residential consumer with single rate meter electricity. Then I will say ZG03 smart meter residential for on peak, mid peak, off peak, and demand. And D. I'll simply say demand. Then I will say smart meter residential consumer again. This is another building class I define for, we will say, the consumption below limit, consumption above limit, and amount for the consumption above the limit. Okay. So we will say time of billing. So we can say, let me keep it on hold. I'll give the proper definition for that. Then I will say commercial and industrial consumers electricity. And I'll say check the G05 fix for fax billing heat light. So some examples I have defined here. Basically, I'll say commercial smart meter residential consumer with the limit concept with the limit. Means we have limits for the on peak, limits for the off peak. As far as the consumption is happening up to the major value less than or equal to limit value, it will use the standard price, or consumption above limit will be calculated with the extra price. So there are two scenarios in the smart meter. So for that, I defined two separate billing class. Now, looking at them, you can see each one of them is identifying a specific scenario. It is unique. Nowhere you see some kind of overlapping. Each of them is uniquely stating the type of installation for which billing is going to happen. Okay. Obviously, first you're going to work with the ZG01 residential consumers with 2 rate meter for the electricity, basically requirement. So we have to find the billing class. So first we'll be working on this 7. After this, we are going to define, let's say, rate structure. In the rate structure, of course, variant program will be required, operand will be required, rate will be required as the initial step of construction of the billing master data. But all three are related to each other. That means when you want to define a rate, we must be ready with the what variant programs going to use, and for that variant programs, what operands are required. And then when you also want to define the rate, for each of the line item calculation, you should have the corresponding integration with the FICA. That means, imagine I define the operands. I have the existing rate type, but I cannot create the rate immediately. First, I must complete, or let's FICA consultant configure the main transaction sub-transaction in the FICA, assign it to company code and division, then you will be in a position to create the rate. In the project, there will be dedicated FICA consultant, and obviously they will take care of this. But over here, we will have to do it. That means as a ISO consultant, we are going to understand all the basic configurations, what need to be done in the FICA. That means by default, at least 20% of FICA we are going to learn as a part of our understanding. Although we may not do it in the project, but here in order to prepare the data, we need to have the data. So we need to have the object defined. So before defining the rate, I will have to define the settings in the FICA. Now, let me go to one existing rate and then see what are the activities you need to define. So if you go to define the rates, change the rate. Let me take one of the existing rate. In this particular rate, this rate has been defined for division 93 and billing class. This is the header level data. This is header level data. That means when you define a rate, certain header level data is applied. This is applicable to all the line items. That means this is a data applicable to the entire rate what you're going to define. So each rate belongs to a particular division and particular billing class. Now, when you define a rate, it is not a free definition. It is bound by permissibility. That means the rate that you define will belong to either register permissible, or is the interval meter permissible, or device permissible, or fax permissible, or waste billing, or period end billing. Now, except period end billing is a report billing. All other permissibility factors are actual billing, where you know the amount you have to collect from the consumer. Okay. Now, waste billing we are not doing. Earlier, we used to have the waste billing also, waste management in ISU. Now, more or less, a separate solution is available from utility from the ISU that can be used. So you're going to work on the register permissible rates definition, interval meter based rates definition, device permissible rates, fax permissible, and period end billing. Except the waste billing, we're going to define all the rates to understand how each one of them can be defined and what is the basic difference. But now, if I want to create a rate, I have the division with me, I have the billing class with me, but I require the operands and the variant program. I require the variant program, I define the operands, and then I have the FICA definition. That means rate is the most important definition that you do, but you cannot straight away do it unless you're ready with the variant program. Now let's assume we're not going to define any variant program. We're going to make the use of the existing variant program. But I have to define the operands, and then I must structure the FICA definition, then I can come and do it. So first we'll try to understand what is rate as a layman, and then what does it contain, what is the contribution of rate in the overall billing calculation, and then we'll start with the definition of the operand, because for defining operand, we have no limitation as of now. You can straight away go and define the operand. Once the operands are ready, I can try to define the rate, but I will not be able to do. After the operands are ready, I'll go to FICA and set up all the required sub-transactions, assign the main sub-transaction to company code with a division, then come here and then start defining the rate. Okay. So first of all, you try to understand what is the variant program. If you understand variant program, then we know what kind of operands you need to define. Okay. So here we have a variant program quanti01. So let's copy this and see where it is defined and what is the purpose of this variant program. Before that, let us try to define the rate. What is rate? Rate can be defined in many ways. We'll define according to our understanding. What are the possible definitions of the rate? Rate is the smallest block of calculation. Smallest block of calculation. That means it's not the overall set of calculation. It is one component which will do calculations for one or many items. But it is not that all the line items what require for calculation can happen through one rate. It is possible that in some situation, one rate is sufficient, but in some scenario, we may have more than one rate. Okay. But having said, it is the smallest block of calculation. Now, rate, this is one definition, smallest block of calculation. Second definition is rate contains one or many steps of calculation. One or many steps of calculation. Each step contains is the variant program used and associated operands. That means if I'm going to define a rate, definitely it will be one step of calculation, but depending on the requirement, we may also have more than one step of calculation. Each calculation is performed with the variant program and associated operands. Okay. So generally, when you say rate in our data understanding, you say price. Okay. We say what is the rate of petrol. Okay. Or what is the rate of sugar, or what is the rate of computer. Normally, we understand it as a price. Okay. Petrol is so and so price, sugar is so and so price, laptop is so and so price. But it is not talking about the price here. Okay. So we should not get confused. We are not talking about the prices here. Prices will come subsequently. Price for on-peak how much, price for off-peak is how much, price for demand price is how much, or rental price is how much. That part is maintained separately. Here, rate is a configuration object. It contains the logic. Suppose I want to calculate the amount, how the rate should be structured. Now, let us say, as a layman, every month I want to do periodic consumption billing for a residential consumer with 2 rate meter. That means this meter is having 2 registers. We first create a scheduled metering order. Then the metering person will go to installation, read the meter, correct the data of metering value for the particular date on the month, and provides information to office. In the data entry, person will enter the metering results. Either you enter manually or upload. Okay. That means you have collected results for on-peak and off-peak. Say, for example, in this month, our on-peak energy quantity is coming to 700 kilowatt hour. Off-peak energy quantity is coming to 300 kilowatt hours. These are data what you have in the system. That means you have the current metering value minus previous metering value. The difference is going to be consumption for the period. So for the particular month, on-peak consumption has happened as 700 kilowatt hour and off-peak consumption has happened as 300 kilowatt hour. Okay. Now, when you want to bill the consumer, obviously the simple logic is on-peak quantity into on-peak price equal to amount. Let's say, for example, this is the quantity, what we have got. Then what is the price? Definitely price will be different and the amount. So we'll say price for on-peak is 15 rupees per kilowatt hour and off-peak is 10 rupees per kilowatt hour. So what is the amount? Amount to be is equal to 700 into 15. That is 10,500. And same way, amount is calculated for the off-peak amount, 3,000 rupees. Then in the billing, we are not going to calculate the tax. Then you say net. How much is the billing amount going to come? So obviously, this will be 10,500 plus 3,000, which is equal to 13,500. Now, this activity is done by a rate. That means I have a rate which will calculate on peak, off peak, and the total will get. But this is what to understand by layman way. But I cannot do both calculation in one single rate. You may say these two calculations can happen in one rate because rate contains one or many steps of calculation. So why can't we define a rate which will do both the calculation? Understanding wise, okay, but at the system level, it will not happen because register permissibility. Permissibility factor will come into picture. That means each rate has to have a dedicated connection with the register. So the on-peak amount will be calculated with the on-peak energy rate. This will be put in one separate rate, and this will go and sit in another rate. That means I cannot do both the calculations with one single rate. Although technically you may say, I have a rate which both line items are calculated, but it doesn't happen that way because of permissibility factor. What is permissibility factor? We will see. Now, I expect when the billing happens, the information should be available and the amount should be calculated. Now, how will the system know this logic has to be applied? Quantity into price is equal to amount. This logic variant program, quantity 01. That means I don't have to write a formula. If I say quantity 01 is a variant program to be used for calculating the amount, if quantity 01 is there, then it will immediately say what is the quantity, what is the price, and then multiplication of that is the amount. That means quantity 01 is the logic built into functional model program. The moment you specify when the billing execution happens, automatically it has to have the information about the quantity and the price, and amount is calculated. Now, when the billing execution happens, everything is happening in the background. You must understand, we don't put any data upfront when the billing has to happen. For example, let's say I want to do billing for a single installation. Billing can be done in three ways: as a single transaction for a particular installation or a contract, or I can do billing for n number of installations at a time as a mass processing, or I can do parallel processing. Suppose if I go to billing and then say billing execution, individual billing, I'm billing for a particular installation or a contract. But here we don't specify any other date except the date by which I can do the billing, document date, posting date. Recon key is optional. If you're going to create billing and invoice also together, then recon key is required, otherwise not required. Okay, so we don't say what is the quantity, what is the price. Naturally, that information you cannot enter. Same way, when you do mass processing, we are mentioning n number of installations at a time. Mass billing, so and so range of installation, or so and so portion. What is portion? We're going to learn subsequently, or based on division. Now, here also we can see we don't provide any information about the data part. That means when the billing has to happen, it has to find out first what rate is applicable. The rate has to be executed. What is the variant program? The variant program has to be used. What are the operands? What are the operands here? The variables. Okay. In order to calculate the amount, we have got two variables as the input operand. You can say this is one input operand, this is an input operand. Quantity is the input operand, price is the input operand, amount is so and so. So simply you say x is equal to y into z. We have got an equation. I have to repeat this for thousands of installation. That means for one installation, what is the value of x amount? Then it has found out for that installation what is y, what is z. Then only it can calculate the amount of x. So y is one variable, z is one variable. So these are called input operand. Output operand means resulting value, which is passed on to the billing. That means end of the billing is amount how much you have calculated. So when the billing happens, it has to find out what is the value for the quantity, what is the value for the price. But how will the system know which one is price, which one is a quantity? So we define two operands. I define y as the operand for the quantity, z as the operand for the price, and x is the operand for the amount. That means you are defining the operands, giving the operand class operand category. When I define the operand Y, I say operand category is a quantity, quant. That means that operand is going to work as a quantity operand. I'm going to define the operand as Z with the basically operand category quantity based price. Again, there are different types of prices, but this price is quantity based price. 1 kilowatt hour price is 10 rupees. So 100 kilowatt hours means 100 into 10. Like one apple is 50 rupees. For 6 apples, it is going to be 6 into 50. That way, amount has to be calculated. So when you define the operand, you define the operand class, you use the operand class. And X is the amount what you calculate. So the operand X is defined for the amount category. Okay. So first you must define the operand. Now these operands you're going to define because of associated variant program. Now quantity 01 is an existing variant program. So if you go to the system, we can see where this operand has been, where this variant program has been defined. Analyze variant program. Now, if you just execute, it will show all the variant programs available in the system. Okay. But we are interested in the particular variant program, quantity 01. Now, variant program is quantity 01. It has got a functional model program. The associated functional module is ISU underscore quantity 01. So there's a convention. If the variant program is quantity 01, associated functional module is ISU underscore quantity 01. Similarly, tomorrow, suppose if you say demand 01, this is for calculating the demand power amount. Okay. Now here demand 01, okay, I entered it wrongly. So demand 01. Demand 01 is a variant program. If you go to functional model program, ISU underscore demand 01. That means if XYZ is the variant program, then associated functional module is ISU underscore XYZ. A convention is used here. Okay. Now coming back to quantity 01, if I go to quantity 01. Now, if I go to this particular variant program, it says, if you want to make use of this variant program, your operand should be defined. 3 operands are required. 1 operand as the input, second operand as the input, third as the output. But this input operand 1 should be defined with the operand category quant. The quant is a system defined category. You can say, I want to define X as the quantity based operand. Then I must use the operand category quant. That means it is giving the system level definition to the operand. Otherwise, how will the system know X will act as a quantity or amount or price? Okay. But if I say I'm defining X with the operand category quant, means it will behave like a quantity operand. Similarly, if I define Y, that is going to behave like a price. But again, price are different types of prices, quantity based price. And third operand I'm going to define for the category amount. Okay. So each of the operand we are having particular category. Now, each of the variant program has got a documentation. So if you go to documentation, here you can see the complete information about the variant program. Now, variant program simply X into Y is equal to Z. We said very simple logic. Okay. Although it is simple, but variant program, what is available here, functional model, has built with all the possible scenario. Like there could be likelihood of, device replacement or price change. All these have to be taken into consideration. So tomorrow what we'll do, we'll go to this documentation completely, and that's how we should do for each and every variant program. But try to understand for one variant program, the documentation, what does it say? I mean, how it has been carefully taken into consideration all the possible scenario with which the logic has been written. Okay. So today we are just trying to bring into picture what are the parameters required in the billing master data. Subsequently, we're going to start defining each one of them. As of now, we defined only billing class. First, we'll define tomorrow operands. Then after defining operands, we'll try to define the parameters in the FICA. Then we'll create our first rate. Okay.
Okay, sir.
Shall we continue tomorrow? Okay.
Yes, sir.
Okay. Thank you.